Myself Prayak Patel, working as assistant professor in IT ICT department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the next topic of combinations. It is called the binomial theorem. Now here we already know what is the combination. Combination means we have a total n element. From the available n element, we have to select r element. How many combinations are possible for selecting the r element from the available n elements? So here consider the one example of the combination is the number of arrangement of the letter T A L L A H A S S E E. So this is a given letter. Now for this letter, how many different combinations are possible? So for that we use the formula of the combination. So here different 11 characters are available. So 11 factorial divided by repeated element in this sequence. So here A repeated 3 times, then L repeated 2 times, S repeated 2 times, E repeated 2 times, and remaining element are single time. So here 11 factorial divided by 3 factorial, 2 factorial, 2 factorial, 2 factorial, 1 factorial, 1 factorial, and answer equal to 83160. Different way possible for arranging these letters. Now here, how many of these arrangement have no adjacent A's? That means you have to find the arrangement like this, no any 2 as adjacent element. So here no element A as an adjacent. That means here 3A are available. So subtract the 3 from the available 11 element. So remaining element as an 8 element. So without A, how many possibilities for remaining element without A? Remaining elements probability combination is 8 factorial divided by 2 factorial, 2 factorial, 2 factorial, 1 factorial, 1 factorial. Because we remove the 3 from lower side and remove the 3 from upper side. So answer is 5040 ways to arrange the remaining letters without A. Now next, one of these 5040 ways shown in this figure is a arrangement of without A element. Now where we put the A? So here in this figure we see that arrows represent the position of A. So here different position are available for the A. So 9 location available for the A. You can put the A in this different position as a 9 positions. So here there are the location selected for the A as a 9 3, because 9 location available, you have to put the 3A. So 9 3 equal to 84 ways for arranging the A in this sequence. Now for arranging the remaining 8 elements, we have a value as a 5040, and for arranging the A we have a value as a 84. So multiplication of 5040 with the 84 is our answer. 423360 as a different arrangement possible for the given letter. Here no A as a adjacent element. So this is a simple example for that. Now some formulas are used for the binomial theorem. So here understand the formulas like way of writing the sum of a list of n plus 1 terms like am plus 1, am plus 2 up to the am plus n, where m and n are integers and n greater or equal to 0. So for that we can use the addition summation of this all. That means we represent this using the sigma notation. So see here, a of m plus a of m plus 1 plus a of m plus 2 plus up to the a of m plus n. So addition of this all are represented using the sigma notation. Sigma I equal to m plus n a of I. So I become m plus 1, m plus 2 up to the m plus n. So this is a simple addition for the sigma. Here I is called the index of the summations. Now some another formulas are available for the binomial theorems is first, sigma I equal to 3 to 7 a of I. That means a3 plus a4 plus a5 up to the a7. Here we represent the j in place of I, then both are equal. So here no different about the I and j. So we can write the sigma j equal to 3 to 7 a of j. Both are equal. Second equation, sigma I equal to 1 to 4 I square. That means here I square means I means 1 square plus 2 square up to the 4 square is equal to 30 is equal to, here we use the starting value as of 0 in place of 1, then what is the difference? No any change, because 0 square is also 0, so no change in addition. That means k equal to 0 to 4 k square is equal to 30. Now third one, I equal to 11 to 100, I cube equal to 11 cube plus 12 cube up to the 100 cube. Now here if we change the limit from 11 to 100, here we write the, in place of 11 to 100, we write the 12 to 101. So our formula is sigma j equal to 12 to 101 j minus 1 cube, because here we change the limit. Same way, if we decrease the limit from 10 to 99, so k equal to 10 to 99, then our inner part is a k plus 1 cube. Now fourth formula, I equal to 7 to 10, 2i equal to, here in place of I we have to put 7, 8 up to 10. So answer is 2, 7 plus 2 into 8 plus 2 into 9 plus 2 into 10 equal to 68. So here we represent the 2 as a common factor. No any variable part in a 2. So 2 as a constant. So we common 2, then apply the sigma. Then 2 into sigma I equal to 7 to 10 I, it is also same. Now fifth formula, I equal to 3 to 3, a of I is equal to, directly we can say that the a3. Then if we change the limit from 4 to 4, then sigma I equal to 4 to 4, a of I minus 1 is equal to sigma I equal to 2 to 2, a of I plus 1. These three are equal. Now last formula, I equal to 1 to 5a, that means a plus a 5 times, that means 5a is a resultant value. So these are the different formulas. Now after that, using this summation notation or formulas, we can represent our previous example. In previous video lecture, we already discussed the one example how we can select or give the answer of the question paper. So according to that, here total 9 questions, here 7 answer is given from the available 10 questions. So according to this, our three cases like this: 5 3 5 4 plus 5 4 5 3 plus 5 5 5 2. So here in this case we represent this equation in a common form, summation formulas like this: sigma I equal to 3 to 5. So first part is 5 3, that means here we write the 5i because I equal to initially 3. So first part is 5 3 and second part is 5 7 minus I. So here 5 7 minus 3, that means 4. So first part is a 5 3 5 4. Now for the second value, if I equal to 4, that means 5 4 5 3. If I equal to 5, then 5 5 5 2. Same way we can represent this equation in form of limit from 2 to 4. So sigma j equal to 2 to 4. Then first part is 5 7 minus j and second part is 5j. So these all are the common form of our previous example. Now here consider the example of the binomial theorem. We consider the certain arrangement called the strings made up from the different alphabet symbols. So here alphabet symbols is like, for example, 0 1 and 2. Three alphabet symbols are available: 0 1 and 2. For example, then you have to consider the two element, find the string of two length. That means different possibilities for that is 0 1 0 2, then 1 2 2 1, like this. So how many different possibilities are there? So total 9 possibilities for find the two element from available 3 elements. That means we can say that the 3 square. So 3 square equal to 9. Now here if we have a 3 element 0 1 and 2 and you have to find the 3 length string, that means 0 0 0 0 1 2 2 0 2, then 1 1 0, like this. So different how many combination are possible for the 3 length? So it is called the 3 cube equal to 27 possible way for combining the element as a 3 element. Now from this we can conclude that from the available n element you have to find the length of 3 element, length of 4 element, length of 2 element, like this. So in general, if n is any positive integer, then by the rule of the product there are 3 raised to n string of length n for alphabet 0 1 and 2. Now here we write the 3 raised to n. Here we write 3 because we have a 3 element 0 1 and 2, and here we write the n, that means you have to find the length as a 2 element, then n equal to 2. you have to find the length equal to 3 length code, then n equal to 3. You have to find the 4 length code, then n equal to 4. So 3 raised to n is considered as a common formula for the finding the possibilities for given element as a 0, 1 and 2. Now after that, here if x equal to x1, x2, x3 up to xn is one of this string, we define the weight of x denoted by wtx. So here x equal to x1, x2, x3 up to xn element available in a string. In previous case, we consider the one string as a 1, 0. So here 2 element is available. Same way, how we can find the weight for the available x1, x2 up to xn element in a x. So weight of x equal to, we can represent wtx. So here wtx, that means x1 plus x2 plus x3 up to the xn. So means addition of each and every component of your string is called the weight of the x. So here for example, our string is 1, 2. Then what is the weight of 1, 2? So weight of 1, 2 equal to 3 because 1 plus 2 equal to 3. Now what is the weight for string 2, 2? So weight of 2, 2 equal to 2 plus 2 equal to 4. For this 2 example, consider as a length of string equal to 2. Now consider length of string equal to 3. Then first string is a 1, 0, 1. Then weight of 1, 0, 1 is equal to 2 because 1 plus 0 plus 1 equal to 2. Weight of 2, 1, 0 equal to 2 plus 1 plus 0 equal to 3. Weight of 2, 2, 2 equal to 6 because here 2 plus 2 plus 2 equal to 6. Now see here, this is a simply weight, how we can find the weight. Now among the 3 raised to 10 string of length 10, we wish to determine how many have even weight. That means you have already know that what is the weight, how we can find the weight. Then here our question is, among the 3 raised to 10 string of length 10, our string length is 10 and available different string as a 3 raised to 10. Now how many have even weight? Even weight then means addition of this all the component of the string is equal to even number. So such a string has even weight precisely when the number of ones in the string is even, because our element in a string is 0, 1 and 2. So here 0 and 2 is already considered as a even. Addition of 0 and 2 is even. But when we add the 1 in this string, then this become a odd number. That means here main factor is a 1. How many number of ones available in a string? So here we can say that the ones available in a even term, then our total is even. There are 6 different cases to consider. If the string x containing no ones, then each of 10 location in x can be followed with either 0 or 2. That means in a string, no any single one is available. That means all the element as a 0 or 2. That means all the 10 element as a 0 or 2. So addition become even. And by the rule of the product, there are the 2 raised to 10 such string are possible. Now here consider the another case when the string containing 2 ones, because here our value is 2 ones, then number is even. If 1 1 is available, then no any possibilities for the even code. So when the string containing 2 ones, the locations for these 2 ones can be selected in 10 2 ways. So we can say that the C of 10 2 ways are possible for putting the 1 in different locations. Now here after that we can represent this type of many possibilities are available. So once these 2 locations have been specified, there are 2 ways to place either 0 or 2 in the other 8 positions. So here we can say that the 2 1 available in our string, that means 10 2, 10 C2 is way possible for putting the ones. Now remaining all thing is a 2 element only 0 and 2. That means we have to put the 0 and 2 in remaining 8 location. And how many possibilities for that? 2 raised to 8, because 2 has a 2 different element and 8 has a different 8 location are available. Length equal to 8. So total is equal to 10C2 multiply 2 raised to 8 possibilities for 2 element as a ones. Now here the number of string of these 4 cases are given in this table. So for example, next possibility is number of ones equal to 4 in a string, 4 as a 1, 4 number as a 1 code, and remaining all element as a 0 or 2. So in this case our common formula is 10C4 into 2 raised to 6. Now if 6 number as a ones, then we can say the number of the string possible as a 10c6 into 2 raised to 4. Now if 8 ones are possible, then here we write the common formula, number of string is equal to 10c8 into 2 raised to 2. If all the 10 element as a ones, then 10c10 is a possibility, because here no any other part is remaining, no any space available for the 0 and 2. So this table represent the all the cases when we put the number of element is a even. So consequently, by the rule of the sum, the number of string of the length 10 that have even weight is, first case is 2 raised to 10 plus 10c2 2 raised to 8 plus 10c4 2 raised to 6 plus 10c6 2 raised to 4 plus 10c8 2 raised to 2 plus 10c10 is equal to, common formula using the summation is equal to sigma n equal to 0 to 5 2 raised to 10 minus 2n. Now from this equation we can represent or write the one theorem or formula is like, for integer n r with n greater or equal to r greater or equal to 0, n r equal to n minus r. So here ncr is equal to nc n minus r, both are equal. So see here an example of this theorem in this table. We can see here n equal to 5 and r equal to 2. Then how many different possibilities for that? So your distinct object are 1 2 3 4 5. 5 element available, 1 2 3 4 5. N equal to 5 means 5 element available, r equal to 2, that means you have to select the 2 element from the available 5 element. Now what is the different possibilities for 1 to 5? So first is 1 2, 1 3, 1 4, 1 5, then 2 3, 2 4, 2 5, then 3 4, 3 5 and 4 5. So see here total 10 possibilities for selecting the 2 element available from the 5 element. Now same way, what is the n minus r? So r equal to 2, n equal to 5, then n minus r equal to 3. So here if we select the 3 element from the available 5 elements, then how many possibilities for that? So in this case also we write the second part of this table. First possibility is 3 4 5, 2 4 5, 2 3 5, 2 3 4, 1 4 5, 1 3 5, 1 3 4, 1 2 5, 1 2 4 and 1 2 3. So here also 10 possibilities. That means if we consider r equal to 2, then 10 possibilities. If we consider n minus r, then also we have a 10 possibilities. That means our theorem is proved, nr equal to n minus r. So ncr equal to nc n minus r. Now here main theorem is a binomial theorem. Now in binomial theorem, if x and y are variables and n is a positive integer, then we write the binomial theorem is like x plus y raised to n is equal to nc0 x raised to 0 y raised to n plus nc1 x raised to 1 y raised to n minus 1 plus nc2 x raised to 2 and y raised to n minus 2 up to the n minus 1 x raised to n minus 1 y raised to 1 and n x raised to n y raised to 0 is equal to sigma k equal to 0 to n ck into x raised to k y raised to n minus k. Now see here in this theorem, our value of x raised to is incremented by 1 and value of the y raised to is decremented by 1. Here first part is nc0, then nc1, then nc2 up to the ncn. So n0 to nn is your combination part, and second part x term part is a x raised to 0 y raised to n, this type of term. So first initially x raised to 0 and last term is x raised to n. First term for the y is y raised to n and last term for the y raised to 0. So increment x by 1 and decrement y by 1. So basically this theorem is used for find the value of the x plus y raised to 2, x plus y raised to 3, x plus y raised to 4 up to the any value of the n. So x plus y raised to 100 also we can find using this formula. So what is the resultant value for the x plus y raised to 2? What is the resultant value for x plus y raised to 3? Like this. So here for example, here we consider the n equal to 4. So x plus y raised to 4. So here x raised to 2 and y raised to 2, then we can say that the x plus y raised to 4 equal to x plus y into x plus y into x plus y. So here 4 component for different part is here. Now here if you want to find the x square y square, that means x raised to 2 y raised to 2, that means you have to select the 2x and you have to select the 2y's. Now how many possibilities for selecting the x? So here you can select the x from the first part, or you can select the x from the second part, or you can select the x from the third part, or you can select the x from the fourth part. So out of the all 4 part you have to select the 2x. So here we can consider the example as a, for example, among the possibilities we can select the first as a x from the first 2 factor and y from the last 2 factor. Another case is a x from the first and third factor and y is the from the second and fourth factor. And all these possibilities can be represented using this table. So here we first possibility as a x selected from 1 and 2. So y selected from 3 and 4. X selected from 1 and 3, then y selected from 2 and 4, x selected from 1 and 4, then y selected from 2, 3. If x equal to 2, 3, then y equal to 1, 4, x equal to 2, 4, then y equal to 1, 3, x equal to 3, 4, then y equal to 1. So these all are the 6 possibilities for selecting the x for this given example. So here we can say that the x plus y raised to 4 is equal to 4c2. Because from the available 4 location you have to select 2 location for x. So total 6 possibilities for selecting the x, which position occupied by the x. Then the number of ways to select the 2 distinct objects from the collection of 4 distinct objects is called the 4c2 equal to 6. Now here in the expression of the product, here common formula for that is x plus y into x plus y into x plus y. If we perform for 2 times, then only 2 times we write this. If we perform this thing for the n time, then x plus y into x plus y into x plus y up to the x plus y n time. So this is the first factor, second factor, third factor up to the nth factor. Now for that, here we can write the equation is the coefficient of x raised to k into y raised to n minus k, where 0 less or equal to k less or equal to n is the number of different way in which we can select the kx. So here you have to select the k number of x and select the n minus k number of y's. So see here common form is nck. Now here formula is x plus y raised to n is equal to sigma k equal to 0 to n c n minus k, x raised to k y raised to n minus k. So this is a formula for finding the binomial coefficient or binomial value for this binomial equation. So here our equation is x plus y raised to 100, then put the 100 in place of n. Then we find the value for the each and every element. What is the resultant term? For example, x plus y square, then our term is like x square plus 2xy plus y square. So same way we can find the value for x plus y raised to 100 using this formula. Now here see the example for the binomial theorem. From the binomial theorem is the following coefficient as a x raised to 5 y raised to 2. In the expression form we can write the x plus y raised to 7 because 5 plus 2 equal to 7. So here how many ways for representing the writing the x? So 7 5 is equal to 7 2 is equal to 21. So different 21 ways possible for that. Now see here. To obtain the coefficient of 5 a raised to 5 b raised to 2 is the expression. For the given expression is 2a minus 3b raised to 7. That means you have to represent this 2a and 3b in different name, like 2a replaced by x minus 3b replaced by y. Then our equation is like x plus y raised to 7. So for the x plus y raised to 7 we write that 7c5, and for the binomial theorem we write here 7c5 into x raised to 5 y raised to 2, because here our formula is ncn minus r. So here 7 as a n, so 7, and k equal to 5, so 7 here 5, then x raised to k, that means x raised to 5, then y raised to n minus k, so 7 minus 5 equal to 2. So this is a formula. Now here we consider the value of x and y as a 2a and minus 3b, then 7 5 2a raised to 5 minus 3b raised to 2. Then here 2 and a both are different, so we can divide this thing. then 7 5 2 raised to 5 minus 3 raised to 2 a raised to 5 b raised to 2. So our final answer is 6048 a raised to 5 b raised to 2. So this is a simple solution for the 2a minus 3b raised to 7. Now here see the one theorem for each integer n greater than 0. First thing is nc0 plus nc1 plus nc2 up to the ncn equal to 2 raised to n. And second part, nc0 minus nc1 plus nc2 plus minus nc3 up to the last part is a minus 1 raised to n ncn is equal to 0. So addition of this all are 0. Now after that, next theorem is for positive integer n t. The coefficient of the x1 raised to n1, x2 raised to n2, x3 raised to n3 up to the xt raised to nt. In the expansion of x1 plus x2 plus x3 up to the xt raised to n. Here we can represent this in form of this common form n factorial divided by n1 factorial into n2 factorial into n3 factorial up to the nt factorial. So this is a common formula for this. Now using this common formula, we can consider this formula as a, we can say the coefficient. Here we find the binomial coefficient means only for the two values. This is called the multinomial coefficient. So this is a common formula for that. Now after that, example related to this is like this. In the expansion of x plus y plus z raised to 7 in the following form, then we find the x square, y square and z cube is. Total value of the x plus y plus z raised to equal to 7. But division of these three is x square, y square and z cube. So here we write the 7c223. So that means 7 factorial divided by 2 factorial, 2 factorial, 3 factorial is equal to 210 base. While 7 divided into x raised to 1, y raised to 1 and z raised to 5, then 7c115. So 7 factorial divided by 1 factorial into 1 factorial into 5 factorial equal to 42. Now third way, for example, we consider the x raised to 3, y raised to 0 and z raised to 4. That means 7c304 is equal to 7 factorial divided by 3 factorial into 0 factorial into 4 factorial is equal to 35. So these three are the different way for representing the x plus y plus z raised to 7. Now here in this lecture we discuss about the how we can find the binomial coefficient, how we can find the different combination. Thank you for watching this video.